Hello. The Sonagashira reaction, advanced organic chemistry. In this reaction, you will be replacing the hydrogen on the alkyne with that R group. These swap. So it's a coupling reaction between that alkyne and this R group. Obviously you need a good leaving group in terms of the halide. So it could be chlorine, bromine, iodine, etc. What's interesting about this reaction is that it takes place through two catalytic cycles, one cycle involving palladium and the other cycle involving copper. So this reaction needs both catalysts to occur in the presence of a base and at room temperature. This bit here is quite important. Room temperature is, well, the closer you can get a reaction to occur at room temperature, the better. No need for heating or cooling. As you can see, your end product is the coupling of the two groups. So here are your two cycles. This first bit is your palladium cycle, and that interacts with this copper cycle almost like the cog of a wheel. You start off with the copper pre-catalyst in the first step. Sorry, palladium pre-catalyst. So you have your palladium pre-catalyst, you add a ligand or take a ligand away usually to get the palladium 0 oxidation state. Once it's in that state, it's activated for oxidative addition. In this step, the alkyl halide is added to the palladium complex. You can see the two parts. There's your R group and there's your halide. This palladium complex then has to interact with the copper cycle. So in order for us to understand the copper cycle, we have to start at a different point. To start over here. So you get a copper halide. That copper halide has a ligand attached to it, which is the alkyne, usually through the triple bond. Forms a slightly weak bond over there. You can see the copper interacting with the sp hybridized carbon. A base then is used to extract the hydrogen, because bases accept hydrogens, and you are left with your copper alkyne. This copper alkyne complex interacts with this palladium complex, and the alkyne group bonds to the palladium group, and the halogen on the palladium bonds to the copper. So you get this mishmash of these two coming together. This couples with this copper, this copper over here to form that, and this group bonds to the palladium, just to recap. Once that occurs, you get your palladium complex. Usually these two have to be next to each other for the next step. In the reductive elimination, the alkyne group in the R1 group, they come off to form your alkyne, which was the product of an R group and an R group. So here is an example in that we want to bond this group here onto this alkyne group. There are your two separated R groups. This could be R1 for instance, that's R2. You can see that the molecule is linear over here due to the hybridization of those carbons, sp hybridization, with nothing happening to the hydroxyl group or any of these side groups. You can see this is a very good example because usually there are variants of this reaction. Here it's very straightforward. There's your copper halide, copper iodide in this case, your base, your palladium catalyst, and your ligand that activates the palladium catalyst, because remember, palladium 0 is the active state of palladium.